Buonasera, tutto bene? Abbiamo iniziato. Grazie Mauro, grazie a Mix che ci dà questa opportunità di parlare di cose tecniche molto interessanti e oggi abbiamo anche due ospiti che ho il piacere di aiutare nella presentazione, anche se non hanno bisogno di me ovviamente. E parleremo di Quic. Facciamo un breve sondaggio, dai, via, capiamoci, siamo tra amici, più o meno ci conosciamo tutti. Chi di voi conosce Quic? Sulle mani? Allora ho fatto bene, via. Allora, diciamo che vi faccio vedere un attimino che cos'è Quic, in modo maniera che poi, insieme a Bart di Cisco e insieme a Peter di Microsoft, che ci parlerà di un argomento correlato, che è l'IP reputation, vedrete qual è poi il problema dello streaming, ok? Quindi sicuramente è un argomento caldo per il presente e il prossimo futuro sicuramente. Quindi andrò velocemente a raccontarvi qualcosa, sempre che... Ok. Quindi rapidamente, giocando con un pochino di parole, facciamo un breve quick look at quick. E poi parleremo, come abbiamo detto, della parte di Encrypted con Bart e del Malicious metric con Peter. Che cos'è il Quic? Quic è esattamente il protocollo di trasporto che ha come obiettivo la sostituzione del TCP. Originalmente fu creato da Google, ovviamente che è stato uno dei primi, no? Antesignani nello streaming su questo tema. E quindi vediamo in rapidi passi che cosa significa Quic, cioè dove va a insistere questo protocollo. Innanzitutto, perché dobbiamo utilizzare Quic? Dobbiamo utilizzare Quic perché dobbiamo distribuire tanti dati, si parla di metadati, a tante persone, su connettività non sempre agevole, non sempre sufficiente, e quindi con l'obiettivo di ridurre il traffico e di aumentare la fluidità del servizio, affinché la nostra mente riesca a interpretare nel modo corretto le informazioni che gli vengono inviate, dicasi metadati. Questa è la slide fondamentale che voi dovete attenzionare, secondo me, per capire bene che cos'è il Quic. Il Quic è esattamente la colonna che trovate alla vostra destra. In pratica, nella parte di protocollare, dopo il livello 3, quindi dal livello 4 in su, andiamo a sostituire la parte di TCP con un servizio di trasporto sicuro, TLS, oltre alla riduzione del protocollo che era considerato sicuro e che lo è tuttora, ma comporta un dispendio di energie e di tempo, che era il TCP. Sicuramente riducendo, Quic è più veloce, più sicuro ed è UDP, quindi non ha più il triple handshake. Oltre a questo, il Quic consente la possibilità di colloquiare in modo interdipendente dalla rete, perché è un client to server, dove il nostro client è il nostro browser. Okay? Tutto questo qui avviene all'interno del browser e consente di avere puntualmente un servizio client to server molto molto efficiente. In pochissime parole, questa è l'ultima mia slide, sicuramente risolve la maggior parte dei problemi del TCP, come abbiamo detto, va incontro a tutto quello che vuole essere la rapidità di informazione che arrivano ai nostri clienti sul browser, ormai de facto il nostro punto di interconnessione uomo-macchina, ok? E oltre a questo ci consente la sicurezza del contenuto, perché anche criptato. Okay? Credo di avervi dato sufficienti informazioni per comprendere meglio il prossimo intervento del collega Bart di Cisco, che invito sul palco a presentarvi esattamente la sua presentazione.
Stage for you.
Thank you. I kind of guessed that you wanted me to come to stage, Marco. So thank you very much for giving me the opportunity to speak here, Mauro and Marco. I'm really happy to be able to discuss this topic, which is near and dear to my heart, which is really giving you a view on the new protocol stack. Marco did a very good introduction on the basics of Quic, and what I'm going to do is give you a view on some of the measurements we've done to figure out how much of this protocol stack is actually floating around on the internet. Also talk a little bit about what implications we see of this new protocol stack, specifically for networking folks, which are plenty in the room, I think. And then also discuss what, from a networking perspective, we think we can do about this protocol stack, how you could work with it in different ways than what has been done typically in the past with pure TCP/IP stacks. So, as you heard, my name is Bart van der Velde. I'm Director Engineering in the CT office for Cisco. And one of the topics I deal with on a regular basis is looking at how to manage IP networks in a more cost-effective, more efficient way. And part of it is obviously this topic. But before we get started, I just wanted to make a quick shout out to the remembrance of Mark, who was a dear colleague and friend that I started this work with, and unfortunately 2 years ago he passed away unexpectedly, and I promised his wife I would keep him at honor on a regular basis for this topic. So, we already had a bit of acronym soup from Marco with a quick look at Quic, but there's actually a full protocol stack being used, and I put a whole bunch of acronyms here on the slide, and we'll talk through some of them. But you have to think more and more, if you're in networking, about the higher layers above pure IP networks and how they affect actually the consumption of the offered bandwidth that you are putting out in the network. But before we do that, let's have a look at some measurements that we've done over the last, we started this in 2020, over the last 3 to 4 years, where we started measuring what certain consumptions you could see on the network. And in 2020, actually, I was pretty lucky with Mark, and we got access to a very large anonymized data set of flow data records of a large US carrier. They asked us to actually do an analysis of their data, and this is kind of the top level items we found, which really started to spark our interest. So first of all, for all intents and purposes, all traffic that you have flowing on your networks today is encrypted. We found then, over 90% of the volume being completely encrypted. So it's kind of the default way of any application running on networks to be delivered. Second important thing, which is, I think very well known, but when you look at the numbers, it kind of is pretty astounding, right? The big logos you see here represent 70% of volume that you will find pretty much on any link in any network across the globe, right? So the distributed nature by which the internet was originally conceived, the any-to-any situation has really become more of a situation where you have a very discrete set of elephant destinations that are kind of sinkholes for pretty much all traffic going around. Another important handle that we saw was DNS, right? If you look at the flows, the flow count on networks, we found then that 50% is DNS communication. So effectively, DNS is the load balancer and the control plane for anybody deploying applications in the world, which is a very important thing to realize. And then comes the Quic assessment. We found this protocol running there to be like 20% of traffic. So we took that and started tracking this quite a bit. So fast forward roughly 18 months, a tier 1 European mobile carrier, and we found that Quic went up in that carrier to 43% of traffic. So in 18 months, we saw a very significant adoption of Quic happening. Some examples, the two very well-known logos, YouTube and Facebook, they essentially have defaulted to Quic for delivery of their mobile application to end users. And actually, Facebook is a very good example. They were running a normal TCP/IP stack for their applications, and overnight they upgraded the app and they switched essentially to Quic fully, right? So you have an application-driven adoption of the protocol stack that Marco was showing. And some more data sets here. So overall volume by applications. The internet gets narrower and narrower with massive destinations, right? So the big 5 popular applications that are sitting undoubtedly on your phone, you can see the logos here, Facebook, Instagram, YouTube, etc. They essentially generate 50% of volume today on today's networks, consumer networks, right? Where overall we saw 40% plus minus of Quic traffic. Now on the flow side, it's interesting. It's kind of counterintuitive because Quic can be an extremely efficient protocol to fire up multiple flows very fast. We actually saw TCP sessions to be pretty prevalent. We think that's mostly related to the fact that these large media applications are delivering bulk video for the most part, so they don't need to be that chatty. And also on the TCP side, there's a lot of small communication, transactional IoT style communication happening at this point in time. So we started surveying this across the globe, and not to our surprise, but it's always good to see the factual numbers. This is a pattern that persists across the world. These were measures taken earlier this year. So LATAM, EU, US, all show a similar rate of adoption of the Quic UDP stack. And so if you plot this out, and by no means this is an scientific, fully accurate study that we've done. We've just picked data sets from customers that are willing to anonymously share information and flow information. You see this trend of Quic essentially today pretty much commanding 50% of traffic on the internet. And this, I think, is still a quite largely unknown fact in the networking industry, which is ultimately basing a lot of networking management capabilities on certain sets of assumptions which are derived from TCP/IP behavior. You probably noted that I talked about mobile traffic for the most part in these slides. That's the assessment we had there. But we also sampled a fixed broadband operator, and we came to the similar conclusions. The data sources might be different. There's quite a bit of generic CDN destinations there, like CloudFront or Akamai. But that's essentially the nature of the beast of PC-generated traffic versus purely mobile app-controlled traffic, right? So, let's take a little bit of a look to this new IP stack in a bit more detail. So, first of all, as Marco already showed a similar slide, but I want to extend it with a few extra pieces, right? So first of all, the new application stack is one that is constructed of HTTP3 running over Quic TLS 1.3 on top of UDP, a fire and forget protocol. But then in addition, I talked about DNS control and DNS being so important for application control. There's now a protocol which is called DOH, DNS over HTTPS, which essentially encrypts fully the DNS communication between the client and the server infrastructure that is typically responsible for delivery of the content that you're trying to access. On top of that, there's also things like encrypted SNI, so encrypted server name indicator, and encrypted client hello, that are now in the process of standardization or are already standardized, that essentially further the inability to actually look at certain sets of control elements that are floating on the wire should you be looking at observing the wire. So you have a stack that gives you improved security, multi-session capabilities, a very application-centric and friendly design paradigm, and then start combining it with a DNS non-observable control plane, as well as target domain selection and target domain communication being fully opaque. Which essentially leads us to the conclusion that for this kind of protocol stacks, the traditional deep packet inspection, where you glean some of this information and start combining it to figure out what is actually flowing on your network, what application, is being rendered obsolete, right? So DPI is becoming increasingly ineffective for setups that are being put together the way it's depicted here, for applications that run in this kind of environment. And then in terms of behavior, Quic is also generating a different capability for the application providers that are, consuming the capacity on your networks, delivering experiences to users. So very fast interaction, quick flows can terminate very quickly. We found them to be terminated like within 5 seconds for a very large majority of the set. There was an interesting study from Uber, which is publicized, where they wanted to figure out whether they needed to move their app to Quic or not. And what they found is they essentially took a taxi. What else would they do? With a PC in there and mobile phones, etc. And they started driving around a very congested area on mobile networks. And what they found is that the Quic stack they implemented actually performed better the more the network deteriorated, the more the network was congested. So Quic has an ability to actually push its way through highly congested networks because it does not have an automated TCP back-off mechanism as you know and love it. And also it's very aggressive in ramping up and grabbing the bandwidth it needs versus a TCP negotiation style connectivity setup. There's some measurements up there that also show you that if you, and this is in a lab done by AppNic, you have Quic versus TCP, 2 sessions of each. You then double the TCP sessions, you quadruple the TCP sessions. Effectively, Quic will guard its portion of the bandwidth that's available and essentially relegate the rest of the bandwidth to the increasing number of TCP sessions. So it does not back off unless the application developer would change the scheduling algorithm to that effect, which obviously they would not. They have no incentive. And so we see that this is actually breaking a lot of assumptions in terms of if you were to do stuff on the wire, i.e. queuing, discarding of packets at the IP layer, that actually the assumption of things will back off, things will improve in terms of fair share distribution of available bandwidth and congestion alleviance are actually being broken. So this is a very abstract view of a radio network, a mobile network, where some of the network level, IP level traffic control on the IP network actually becomes less effective, as well as layer 1 scheduling on the radio. If the radio the time slots are full, Quic will actually grab its part that it needs and not back off to the extent to give bandwidth to others. And there's more. The industry in IETF is actually doing more with Quic than I've just shown. One of the newest things people are working on is MASC, multiplexed application substrate over Quic encryption. It's a bit of a mouthful. There's a test at the end about the acronyms, by the way. But joking aside, essentially MASC is a framework that allows somebody to start tunneling datagrams across the internet, utilizing this full opaque stack, full encrypted stack, so you can actually transport IP over it. It is a tunneling mechanism that is programmatically drivable from various points in the network. And so you will see this appear inside the applications, inside client operating systems, as kind of agents to operating systems, as well as in network appliances to start tunneling whatever you want to be tunneling. And a good example of that is today available on, if you have an iPhone and you have an iCloud Plus subscription, Apple Private Relay actually is an implementation of that tunneling of today mostly their Safari browser traffic, where they use it to essentially decouple users from content, and they do a dual hop kind of tunneling mechanism where they disassociate the end user from the content he's trying to access. So the content doesn't know where the content is going to, and the subscriber is invisible for the content side of things. It's a privacy feature. It's just a way to look at things as you are implementing this kind of technology. So the implication there is essentially that in a service provider or a networking provider domain, you have much less insights on the traffic. And you have to start thinking about these ingress proxies, these software ingress proxies into content domains, into application domains as kind of services and identity anchor points, which are going to be able to harvest data as opposed to you potentially previously. And I talked about a lot of consumer applications, but you also see that Quic, for instance, at Microsoft, and I'm not picking at Microsoft, Peter, the next speaker, but Microsoft is using, I think, successfully Quic in their application to make sure that your PowerPoint is rendering, fast on the Office 365 service. And essentially, they are exploiting the technical advantages of this technology to render the quality of experience easier and better. So it is essentially a stack that is fully in business, right? It should be something that we take as a kind of a starting point for us to think about what we do about networking. And in case you weren't convinced yet of this is kind of the ramp up in IETF of various elements that I discussed as they have gone through ratification in RFCs for anybody to essentially ingest and use, right? And I think also we shouldn't forget that consumers are seeing benefits, right? These apps work really well. So in case you got it, you misunderstood me, I am not saying that this is a bad thing, right? The consumers are seeing benefits, so we have to find a way to deal with it and start adding value add on top of these stacks within a networking environment. So this is a little bit of a slide for some food for thought. It's very generic, but certain network services that are being offered today, functionality that we are doing, need to be thought of as up for revision and verify the assumptions on which they have been built. Zero-rated apps, regulated services such as traffic interception, site blocking, DNS blocking, all these things now just became X amount times more difficult, and you have to look at different points where you can actually get that information. So there are certain things we think we can do with this, and I just wanted to share some thoughts we have in this space in terms of actually observing traffic. And essentially we started from a bunch of customers that had questions around I am managing today video downloads versus video streaming. I'm doing certain limits of the speed that one of these services can have. It doesn't work anymore in a quick world. What can you do? Can you differentiate my service definitions in terms of quick being used in Snap for videos versus the Snap overlay functionality? I'm breaking some of the applications. I just want to do accounting. How do I do this? More generically, a lot of networking providers are actually looking for an ability to actually understand what's going on the network and to some extent intervene and apply their services to this traffic as well. And so we thought about this, and this is kind of the almost obvious conclusion, right? There's one thing on a network that's not going to go away. It's essentially the IP header and the time domain that you can observe those packets flowing by, right? The header is not going to get encrypted because then you can't route the traffic, obviously. You can look at the volume, you can look in the time domain how much packets are flowing from source to destination and vice versa. And can we use that to actually build something that actually allows you to interpret what's going on in the network rather than looking inside the packet flows and trying to do that when everything is getting encrypted? Because the reason is that you can actually categorize certain applications in the time domain, right? A TCP video stream looks different in the time domain than a quick video stream, than a real-time video stream, than some other flows on the network. So using this and building a system that can do this, essentially creating a time domain flow recognition system that will essentially say, I'm looking at this flow, it behaves like this, therefore I'm going to categorize it in rough categories of behavioral state, and essentially starting to infer what's going on and what's being delivered on the network. If you can, you enrich it with other information, but this is the ability that you have just by looking at the wire. And then the second thing is to essentially to look at the fluctuating behavior, essentially trying to figure out whether a certain flow is under congestion and having, is backing off or speeding up or changing its behavior by essentially understanding how congestion avoidance algorithms are functioning within both the TCP and the quick step. And essentially, on top of that, once you have that, look at programmatic interfacing of actionability on those derived conclusions that you have on the flows in the network. And so you end up potentially with something that looks like this, where you do the IP header observation in the time domain, you look at the volumes, you observe the flows, you infer what kind of protocols and apps are actually being used on the network. You figure out whether something is constrained, is under congestion, yes or no, and then essentially you can decide to go take a control function like, let's start buffering this flow, let's discard a packet, let's redirect, whatever the case might be. But you get some level of control back into the network that can further your ability to manage your bandwidth, to manage the experience that customers are having without having to try to break the protocol stack. And we think this is actually a scalable approach moving forward, because I did say observe flows, and a lot of folks might think that, okay, this is a totally unscalable thing because there's so many flows, and how are we going to keep track of things? But essentially, what we're trying to do here is essentially look at the interesting pieces of flows that you are going to act upon and let the rest go, right? This is not a system that will try to capture everything and then control everything. The only pieces you're going to be controlling is the ones that are beneficial to be managed towards the bigger aggregate capability of your network infrastructure. So you only use state when you have to, and just let the rest go take its course on your network infrastructure. So this was a very quick run-through of quite a bit of data and information, I do realize, but I hope you got the message that we need to start thinking as an industry on how we are going to deal with these ever-evolving application protocol stacks, what we can do in the networking space to actually do the business we're good at, which is give good quality connectivity to end users, whether they're enterprise or consumers. And we need to start working on this now so that services portfolios of operators can evolve with this as opposed to against it and all of a sudden become ineffective. And the path forward is to look at the IP infrastructure and derive conclusions from there.
Thanks a lot, Bart. Just a moment. Ci sono domande. Io mi aspetto almeno 25 domande, se non 35. Allora, abbiamo visto che è chiaro che il mercato ormai... Ah, prego.
I have a question for you, Bart. About the different figures among the quick usage between different geographic regions. So
Yes.
I saw Europe is 42%, while US is 32%. What is your best guessing about this phenomenon, starting the fact that usually over-the-top players have a very stable and aligned infrastructure and stack of services among different regions?
To the largest part, I think it's my level of sampling as opposed to a real massive difference. We kind of saw a bit of an outlier in the US. We didn't do a full sweep of all the operators in the US. Also, I think there's quite a bit of PC-driven traffic on mobile networks in the US, more than what we have in a region like Europe, and that is also driving less quick adoption because it depends on the operating system inherent capabilities. So there's some discrepancy possible from that.
Thank you.
Ci sono altre domande? Vi dico due cosine semplici. Avete visto, l'RFC è il 9000, facile da ricordare. L'altra cosa che vi volevo dire è che abbiamo detto che il Quic sostituisce l'UDP e noi però conosciamo un altro protocollo che usiamo quotidianamente noi operatori, che è il BGP, che è fatto in TCP. E perché non farlo in Quic? Difatti c'è un draft per fare il BGP in Quic. Ok? Questa è una cosa. L'altra cosa che abbiamo visto, che è il motivo per cui vedremo la prossima presentazione, è che molte delle cose che vengono fatte vedere sul browser del nostro cliente non provengono dagli IP, dai primi IP, ma dai secondi, dai terzi, il tunneling. Sono offuscati. Quindi il modo tradizionale di fare peering al mix non è più valido. Il traffico non arriva dal primo IP. Quindi il consiglio credo che sia semplice: porte grandi, quanto? Tanto, quanto? Di più. Ok? Perché? Perché ovviamente il traffico potrebbe arrivare da qualunque parte e questo è il motivo per cui molti operatori hanno difficoltà anche a indirizzare il traffico, perché il traffico non viene più indirizzato come veniva indirizzato prima, ma avete visto viene indirizzato in modo diverso, peraltro con più flow. Quindi lo stesso cliente potrebbe ricevere traffico da 2 IP diversi, da 2 sorgenti diverse, da 2 ingressi diversi. Ok? Come avete visto c'è un problema di sicurezza e ora parliamo insieme a Peter di Microsoft, di Malicious Matrix, perché a questo punto è molto importante sapere, non è risolutivo, però è importante saperlo, quali sono gli IP, da dove arriva il traffico, come avete visto col teschio, non è più secondario e interessa anche noi che facciamo trasporti, che facciamo peering, perché poi aumenta il traffico, aumentano i problemi, aumentano le cose. Quindi è importante anche conoscere bene l'affidabilità del traffico, da quale parte arriva. Ho il piacere di invitare sul palco Peter di Microsoft, Peter Cohen.
Grazie.
Please.
Thank you. Thank you for having me. Thank you, Mauro, and the Mix, and Daniela, and everyone for having me here. I thought I'd give a little bit of background here about myself. I live in the Washington, D.C. area. Parlo l'italiano molto bene. And I've been in peering previously at 1299 for 5 years. I spent 7 years at Netflix working on interconnectivity and caches. So that's both sides of the business, right? You have residential consumers or wholesale, and then you have content delivery. I worked at 3 data centers, so we also have the part where you're housing hardware. And I've been at 3 years in cybersecurity now. I was at a company that was bought by Microsoft. I've been to Italy many times. I always love to come here. I always feel like I'm at home when I come back to Italy. I don't know how many times I've been here. It's more than 10, so it's quite a few. I should speak Italian better by now. I'm married with 2 boys, and I really love tennis and golf, wine and pasta, and travel. So, a bit about the presentation and everything. Some of the most important things are right here, which is in this list of things I'm talking about, they're from the last 30 days, so it's fresh IPs, so to speak. And these are IP addresses that we have 100% confidence are bad, and they're command and control IPs. So this is a subset of many of the lists that Microsoft and other companies have, and I'm sure some of the IPs are on many lists. So a few metrics, where are they, and what about Italy? So what does it look like? This is kind of what the table looks like. There's a few more fields, but you have a tag, you have the IP address, the port it's running on, and timestamp. Those are probably the most important fields that are in there. There's a few more with headers and so forth. In this list, if we take that 100% confidence rate, we have about 40% of them are at that number. Certainly less in other groups, and this is all calculated automatically for those distinct IPs. Some of them show up a lot. What does that mean? That means that a single IP address will have many, many, many C2s attached to it, running on different ports. And certainly in this list, when I grabbed it, this one IP address seemed to have a lot more than all the rest. So there are cases where you have a single IP address that has many cases over the last 30 days of showing up. In this case, more than 1,000. So where are they, right? And so when I say where are they, this is the geography of the IP address, the physical location. So where in the world are these IP addresses? This is the breakdown. I think if you went back a couple of years, South America would be much smaller. It's growing as time goes on. North America, as you can imagine, where many of them are, some in Europe, and then in Asia. What about the top 10? Where are the top 10 IP list of all the IPs in the last 30 days? Well, they're in China, they're in the United States. Brazil has come up a lot in infected hosts. We have something going on in Morocco and Japan that seems to be, I think, temporary, as well as Tunisia. So things change over the course of time, and this is from a week ago. It very well may look different today. So this is a kind of a segue, as we say in English, about the success of data center, of hosting businesses, VMs, bare metal hosting and everything else, and Italy, which is the success of those types of businesses attracts malicious IP addresses or malicious users, and you should know your customer and everything else. So the next slide is perhaps Italy not being as successful in, and I did this with AI, by the way, I think that one. Italy not having as many malicious IPs, perhaps because there's not as many hosting companies based in Italy. So if you look at this, and you only have 2.5% of Europeans' bad IP addresses are in Italy. That's incredibly low. That's a good thing, right? This is good. And is it because the hosting companies bought co-location in the Netherlands and they bought it in the Czech Republic and in Belgium even, and Germany and France and so forth? And perhaps this is the reason why this number is so low that Italy has done really well. If you were to take that number and divide it by either population or the IP addresses announced by Italian ASNs, you would have a very, very small percentage, and Italy would, my guess would be number one for the least amount of bad IP addresses in the country. But there are a few. So, where are they? And as you can see on this scale, this is a very small number. Okay? So where are the IPs? No surprise, Lombardy, which is where we're at right now, right, Mauro? And Milan. And Veneto, and Sicily, and Latium, and Apulia, and everything. So they're in a few places, but there's really very few, so it's not really significant. But perhaps if you went by city, again, they're in Milan, which is no surprise, and then a few other markets. It's hard to read this chart, but you can see. So, what about these IPs? And so what I did was, I looked at the net block, the prefix, where the IP is, right? So maybe it's a /24, maybe it's a 22, maybe it's a 23. And I said, where is that block registered? And so of the IPs in Italy, 30% of those blocks, which is 54 blocks, or 54 blocks are Italy. That's where the block is registered. And then the rest of them means that the prefix belongs to some company that's registered somewhere other than Italy. And there's an Italian ISP, or that network is in Italy, and they're announcing them in this country. So I thought this was kind of interesting. So, what's next with this? Which is, Microsoft has this list of malicious IP addresses, and I thought, what could we do with this with Italy or what have you? And I have a few ideas. And so, let's start over here, right? Which is integration with software packages, which is Microsoft. We'd like to work with companies to have this IP list in the software. So for people who are looking at flow traffic, when your IP address or when your net flow hits one of these, perhaps you can be alerted. So this is like, software and hardware sort of integration. We tried to do some net flow analysis for people just for helping them if they didn't have software. And then sort of finally, we have this idea, which is perhaps there could be something, if this is interesting to Mix members, we could have integration with the portal at Mix for IPs. And there's two parts of this, right? We could have, you're an ASN, and here's an IP that happens to be on your ASN. I wouldn't know your customers, your downstream ASN, but if you're the originating, you're the last ASN in the path, and the IP is a member of that, then we could perhaps notify you. And then secondarily, could it possibly be on the flow through the switch? Would be another idea. So that's pretty much it. How about some questions?
Abbiamo domande? Comunque abbiamo visto, thank you.
Yeah.
Abbiamo visto tante cose molto molto interessanti.
Sorry, just a question. Peter,
Yeah.
could you stay? Of course, we had more or less this idea of, say, integrating this information in our customer portal. And I would like, well, first of all, to thank you for having delivered us, say, a very positive message.
Yes,
because
for sure.
At the end of the day, Italy seems to be a safer place than many others in Europe, because we have, not a significant amount of breaches or say bad IPs under your classification, but given the number of IPs we have and the amount of internet users in the country, we have very low percentages, for instance.
Yeah. I think the message of that is perhaps Italian networks know their customer better and have a better process to make sure that the customers are not, doing malicious things and have a good reputation as a customer, because no one goes out trying to sell to networks or companies that operate, malware or anything else. That's not anyone's, hopefully no one's business. So Italy, I think, has done a good job of screening. And it might be, we should have talked about this, perhaps it's in the process of buying something in Italy requires something with banking or some check that other countries are not doing. It's possible that I don't know.
It's a safe country.
Yeah, that it's a safe market for doing this. And so that can make it difficult for someone else to set up shop in the country because they don't have the proper bank account or something that is scrutinized that may not be the case in another country.
And so my question goes to the audience and all the mixed members that are still here listening us. So if you have a feedback for us and you would like to see this integration happening in our customer portal, please let us know so that we can arrange this. It's a very simple thing. And I would like to stress the fact that this information will be kept private to each member.
Yes.
So each, I would say at least each admin contact for able to, with the admin privileges, to work on our customer portal, which is the highest level of power, able to do things like, changing the service itself, will have access also to that kind of information in a controlled way. So that could be, the best option for us to deliver this information. So
yeah.
Thank you for your feedback and thank you for your presentation.
Oh, Greg.
Hi, I'm Alessandro, chairman at Mix. Thank you very much for coming. It's a very quick question. Is related to the block list.
I'm sorry.
Is related to the block list?
The block,
Yeah. Is it something that you share with the others, or is it like a way of communicating with other players, like the over-the-top, or is just Microsoft?
So every hyperscaler has some list of IP addresses that they maintain. I think there's some sharing going on between some of those networks to have them. There's a different tolerance of how bad something is before someone may decide to null route it. A quick story. A friend of mine, he runs a website in the States, and for 24 years, he worked with me at SkyCache. He has a website, and it's for parents, because he was a new parent. They built a website and everything. And 22 years ago, it was a long time ago, he said to me one day, he said, there are some countries, they never need to see this website. And he just filtered out entire networks because they would never need to see something for families in Washington, D.C. There was just no need. So he started that policy many years ago. And so some companies have a very high tolerance for what they will filter. And other companies, in my opinion, companies meaning like a hospital, should probably filter a lot more and let Telecom Italia filter for them, but even they should filter on top of that. They should have a direct, there should be many prefixes they never see. And so different companies have different tolerance because Microsoft, we have Windows updates and Apple has the Apple updates and Google has Android updates. So there's a lot of things they have to still be able to reach. But as you go down, there's less and less need to see the whole internet, quite frankly. There are parts that they probably should never see.
Any more questions for Peter? Okay. Thank you again.
Thanks. Desideravo ringraziare ovviamente tutti voi di aver avuto pazienza, tempo di ascoltarci. Spero che la presentazione sia stata di vostro gradimento e vi abbia quantomeno aperto nuove strade su cui indagare, su cui studiare, su cui andare avanti. Piccolo dettaglio, tutto quello che abbiamo detto è solo relativo all'IPv4. L'altra storia si chiama IPv18, no, IPv6. di cui parleremo la prossima volta. Grazie, buonasera.